Hello class, welcome to Algebra Lesson 3.5, which is all about scatterplots and lines of fit. By the end of this lesson, you should be able to use a scatterplot to describe the relationship between two data sets. So let's start by understanding the association between our x values and our y values. So this first graph we're looking at talks about the temperature after sunrise. So our x value tells us how many hours since sunrise, and our y values tells us the temperature it is outside in degrees Fahrenheit. And as you can see, as time is increasing, right, as we go from left to right, our x value is increasing, 2, 4, 6, 8, 10, right, going up. As our x value increases, our y value is also going up, right? We started below 60 degrees and we're ending up in the 70s. So our y value also increased. So when both your x and y values increase, that is called a positive association. Now let's talk about temperature after sunset. Okay, so now the sun's gone down, so it starts warmer, and as time passes, it gets cooler and cooler throughout the night. So you can see, if we look at our x values, hours after sunset, x is still increasing, because we're going 2 hours after, 4, 6, 8, 10. But as our x value increases, our y value is going down, right? That temperature is getting cooler. That's called a negative association. Then, what if we look at the relationship between hours after sunset and the amount of rain? So you can see, as hours after sunset increase, our y values, the amount of rainfall, it's kind of all over the place, right? It just looks really random. That means there's no trend. That means there's no association between these two data sets. So why don't you look at this graph right here and determine, is this a positive relationship, negative relationship, or no relationship? Good luck. Hopefully you determine that this is a positive relationship. As my x increases, my y is also increasing. Okay, why don't you look at one more? Good luck. For this one, hopefully you realize as x increased, our y values, again, were kind of all over the place. There was no general trend, so that means that there is no relationship for this graph. All right, example 2, understanding correlation. So if we look at how can the relationship between the hours after sunrise, x, and the temperature be modeled, you can see I have that same graph as before, but now there's this line, this trend line that has been drawn into the graph. And what that trend line does is it allows us to kind of predict what temperatures might be given that trend line. So we already determined that this has a positive association between our x values because they're going up and our y values because they're going up. So this is a positive correlation between our x and y values. And then what can happen is if it goes the other way, if that line goes the other way, like it would for that sunset problem, that would be what's called a negative correlation. Okay, so positive correlation is when both x and y are increasing. Negative correlation is when x increases and y decreases. And no correlation is when x increases and y just kind of jumps all over the place. It doesn't have a pattern. Maybe goes up and then down and up, down. It just will be random. Okay, so for question 2, I want to see if you understand the correlation. So if you look at this graph and you determine the relationship between sunset and temperature, I want you to figure out, is this a positive, negative, or no correlation example? Good luck. Hopefully you realize that this kind of has a negative correlation. As x increases, my y values are decreasing. I tried to draw kind of a trend line in to the graph for you guys to see. All right, example 3. write the equation of the trend line. So first of all, trend line models the data in a scatter plot by showing the general direction. So those lines that were just drawn on the last two graphs, those are trend lines. And you always want your trend line to fit the data as closely as possible. So when you're drawing those in, you want them to go through as many points as you can, okay? So step one, we're going to sketch a trend line for the data. So if we look at this graph, you can see that we have a graph talking about the electric hybrid cars sold starting in year 2000, and then seeing the number of cars sold in thousands as time goes on. So you can see drew in a trend line, kind of cutting our data in half, or as close to in half as we could. The trend line sometimes is going to go through points and sometimes it won't. It's okay if a trend line does not go through existing points. So the graph took or drew in a trend line, and then they just labeled 2 points that actually didn't exist on the data already. They just made up their own points on their trend line, and that is totally okay. So then what you want to do with those points, you want to pick 2 points, because then you can write an equation for the trend line, which then means you can use that equation to predict future outcomes. So they had picked the 2 points, 250 and 16,500. So they found the slope between them just like we did in chapter 2. So they did y minus y, so 500 minus 50, over x minus x, or 16 minus 2. When they did that, they got a slope of about 32.1. And I know last chapter I talked about how I never want you to use decimals for your slope. These scatter plots are going to be an exception to that rule, okay? You're going to definitely have some messy numbers with decimals, and that is okay for this chapter. All right, so use the slope and then one of the points to write an equation in slope-intercept form. So last chapter we practiced writing things in point-slope form and then transferring them to our y-intercept or slope-intercept form. Okay, so then they just plugged in the point 250 with their slope and then solved to get to slope-intercept form. If you have questions on how they did this math, please reach out to ask for some help. That is what we learned last chapter, but I realize some of you are still trying to get the hang of that, and that's okay. So be sure that you're asking questions. Don't be afraid to reach out for help. And then something important to know with trend lines is your trend line might look different than mine, and your trend line might look different than your neighbor's. It doesn't mean it's wrong. It just means that it's different. As long as your trend line is kind of going through the middle of your points, you're trying to get it kind of halfway through best as you can, I'm going to accept your answer, okay? It doesn't have to perfectly match mine. There are lots of correct answers. Okay, and then the last thing we're going to practice is interpreting trend lines. So the table below shows the amount of time required to download a 100 megabyte file for various internet speeds. Assuming the trend continues, how long would it take to download the 100 megabyte file if the internet speed is 75 kilobytes per second? So you can see that we have our internet speeds 35, 40, 45, 50, 55, and 60. And you maybe noticed that what we're looking for, 75, isn't on this table. So that's going to happen a lot. A lot of businesses make graphs with trend lines to try to predict the future, try to predict outcomes. So this is a very real world example of math, okay? So we don't have the data for 75, so what we're going to do is we're going to use our pre-existing data, or as close as we can, to predict the future. And while it won't be perfect, it'll give us a good ballpark estimate. So first, we're going to plot the points and then sketch a trend line. When we draw on that trend line, we can make a couple of nice points. We can say 40, 6. That's pretty close, right? We have a 40 and then a 5.82. I'm going to make that a 6 to make my life a little bit easier. And then 55 and 4. 4.23, that's really close to 4 as well. So that's why using two slightly nicer points than what we're given in order to find my trend line. So I'm going to use those 2 points and do that same process as before. Find the slope, so 40, 6, 55, 4. You do your y minus your y over your x minus your x. You end up with a negative 0.13, and then plug it in to get into that slope-intercept form. Okay, so the equation they got was y equals negative 0.13x plus 11.2. Okay, so again, this is all review from Chapter 2. If this still doesn't make sense, ask for some help. Then step 3, you're going to use that equation that you just found, and you can use that to predict other outcomes. So in this case, we wanted to know that if the internet speed was 75 kilobytes per second. So we're going to plug 75 in for x. So I'm going to say y equals negative 0.13 times 75 plus 11.2. And when I plug that in, I end up with 1.45. So that means the download time at internet speed of 75 kilobytes per second, the download time would be 1.45 seconds. Okay. Here is a nice little concept summary of scatter plots and trend lines, positive associations versus negative associations, and correlations. So looking at your graphs. If you have questions on anything from this lesson, please don't hesitate to ask for some help. I am more than happy to help you. Have a great day.